Hello guys, today we're going to start the John Deere 9560R build. It's going to be a big build, so it'll be split over a number of videos, and today's video is going to focus on the circuit diagram. Okay, so first thing we need for our John Deere 9560R build is to get a circuit diagram. So we go to www.rctractors.net. On the home page here, we need to go to the RC Tractors tab and go down to RC Circuit Diagram and click there. And now on the RC Tractors Circuit Diagram page, we go down to here, this green button. This is a link to PDF, so click here. That should open a PDF. Okay, so now that you've downloaded your circuit diagram, you can see that this is for a 3.7 volt tractor. We have our on off switch. Power goes to our XB, and I found that XBs, the Series 1 XBs, are able to operate at 3.7 volts without much problems, but you're not supposed to be you're supposed to keep the voltage to 3.3 volts. So if you want to be very careful, that's what you should do. You should keep that to 3.3 volts. The power also goes to our Arduino's VCC pin. The raw pin is for the voltage regulator on the Arduino. Because we are below 5 volts, we want to bypass that. If you were using any voltage over 5 volts, you'd have to use this raw pin. So you would connect your battery to this raw pin. But we're under 5 volts, so we're going to stick to the VCC pin, which is going to feed directly to the Arduino. Now that makes a difference from the current that we can output from our Arduino. If you use the raw pin, the voltage regulator can only handle 100 milliamps. So on outputs like LEDs, you could only maximum output 100 milliamps. But because we're going directly to the chip, we can output a maximum of 200 milliamps total. So from all your pins leaving your Arduino, you can't take any more than 200 milliamps. Now each pin can only output 40 milliamps max, so you need to limit that with a resistor. So if you're putting an LED directly from an output of an Arduino pin, you have to limit the current with a resistor to under 40 milliamps. And in this diagram, the resistor values they don't mean anything. You need to choose that resistor value based on the characteristics of your LED. And just to be sure, when you test this circuit, you should measure it with a volt or with a multimeter, so that you know for sure that your current is under 40 milliamps. Now, if you're going to be using super bright LEDs like you would for the spotlights, you would need to use a transistor. So you would choose this resistor value based on the characteristics of your super bright LEDs to make sure that you get enough current. Your transistor should be able to handle that current. Most transistors are able to handle 100 or 200 milliamps, and that should be more than enough for a couple of LEDs. And then this resistor here, you usually take 1000 ohms, so 1k resistor here, and that will go to the pin of your Arduino. That prevents you from drawing too much current from your Arduino again, so it's just another protection. So this transistor is going to act like a switch, and it's going to power these LEDs. Now, because we are syncing this current, so when you sync a current, you go from the load to ground. So we're using an NPN transistor. If we were sourcing it, i.e. we were trying to switch from here, so that would be from the power source to the load, we'd use a PNP. So we're syncing, so we're going to use an NPN transistor. And you do that for all your LEDs that are going to take more current than your Arduino can provide, or any LEDs that require higher current, or if you've run out of possible, if you're bordering on your 200 milliamp limit, you have to use a transistor. So the last thing we need to look at is our servos. So we have servo for our steering, obviously, our motor controller. This is the motor controller that I showed you in the other video, so just check out that video on how to use this. You'll see the wires here are different colors. That is just so that you know that they're not connected. So this green wire and this orange wire might run along the same line, but they're different colored, so they do not connect. Whereas this red one runs into this red one, so they are connected. Runs across the blue ones aren't connected to the red one. So that's just the way I kind of tried to distinguish the wires. So then the last thing is this link servo. Okay, so you might want to add control of your link arms. So your 3-point link, you might want to be able to lift that up and down. So you can add this servo in if you like. Alternatively, you could take these 3 pins, put them on a female header, and put that below the link on your tractor. That way you could put the servo on whatever accessory that you had, so the accessory would really be lifting itself rather than the link lifting it, and that might give you room to put a bigger servo in. So it's up to you what you want to do there. And the final thing is, I normally put some female headers on the rear of the tractor. That lets me add extra battery in. So here's the ground and the 3.7 volts. So if I had a battery in the trailer, I could just connect that there. And these other 2 pins then, they go to a servo or a serial output. So your serial output you would use to control lights on a trailer so that they matched exactly what was happening on the tractor. And a servo output you could just use to very quickly control a servo. It's very simple. So that's everything. Once you've printed out this circuit diagram, we can start to make a test board on our breadboard. Okay, so now that we have our circuit diagram, we can have a look at the parts that we're going to need. So obvious things that we're going to need for this mock-up: we need some breadboards. You probably get away with one is probably enough. I'd get one like this which has interconnected power lines. It makes things a little bit easier. You're going to obviously need a Arduino Pro Mini. So you'll probably actually install one like this, but this one with the header pins soldered onto it. We'll use that for testing because we can push that straight into the breadboard very easily. Whereas this, we're not going to get good connections if we try to just put wires into it. It won't be good. So we'll save that for later. We'll install the finished code on this one. Install this into the tractor. Speaking of which, we obviously need our tractor. As we've seen in the previous videos, I already have a motor in here. I have a servo for steering on the back, so a servo in there. I also have some LEDs on this, so there's a couple of things already in that. We are going to need lots of wire to make our mock-up. We're going to need our motor driver. We'll need an XB or whatever radio module you're using, and we need a breakout board for XB because this is a 2mm head spacing or pin spacing, and this board here adapts from the 2mm for the XB into 2.5 for the board. So we can just push that into the board then. So that's that. Then you're obviously going to need your battery. We have another servo here to be the link servo. We also have some resistors for our LEDs. We have a bunch of LEDs here, some transistors, and we're going to need a controller to test it at the end. And also I have a trailer here because we're going to need to drive this tractor around to test that it's working. So what I do to test the tractors is I put the breadboard into the trailer and wire it to the tractor so that the tractor can move without pulling the wires. So that is what we need. So I'm going to clear the table off now. Get rid of the LEDs for now. They're going to be the last thing we worry about because they're very simple. And we're going to start working our way back along the breadboard. First thing is going to be the motor controller, then the Arduino, then the XB, because they're the 3 most important parts of the build. So let's get started. One thing that you might want to get yourself is some of this single core wire. So you can get that and cut it into shorter lengths that you want, so that you know, to make it easier for yourself when you're making this board. And a handy thing you can also get is, if you look up on eBay, there's lots of places that sell these little jumper wires. You know, they're kind of long at some point, so when you have these kind of 3 or 4 modules, those long wires can kind of get intertwined and it gets a little bit complicated to follow. So sometimes getting some of this wire and just cutting it to the right lengths can make things a little bit easier for you. So like I said, I'm going to put this breadboard into the trailer so that I can test the the John Deere later. So what I'm going to do is start with the motor driver chip here, because the motor is in the front of the tractor, so this is going to have to stretch the whole way to the front of the tractor, the wires from this motor driver, for me to test it. So I'm going to put the motor driver here and XB at the end, because the Arduino is going to be in between the XB and the motor driver, obviously, because you know, you want to minimise your distance if you can, to minimise the length of your wires. So we have our pins labelled on the back of this board, so I plan to put it in like this. I don't want to solder these pin headers in here, because I only have one of these boards and I want to use it in the tractor. So I'm just going to press fit them in. I'm going to just put the pin headers in at a bit of an angle, get some holes in the breadboard that are going to kind of put some pressure on it when I push it down. I'm not going to push it down so that I break the board or anything, just push it down so that there's a contact between the header pins and the pads on the board. So, but I'm not going to do that just yet. I'm just going to put the header pins sitting in here for now, so that I can still see the pins on the back of this. So outputs are going to be on this side. So at the top here, our first 2 pins are going to be V motor. So let's first wire up our motor driver. So first 2 pins, the V motor and the VCC for the chip. So I'll put that in here to the power line. And just so that I don't forget, I'll connect the 2 sides of the power lines. So you have red and blue here, positive and negative, red and blue here, but these aren't connected to each other. That would mean if you wanted 2 rails, say you wanted 3.3 volts in your system and 5 volts, you could put 5 volt here and 3.3 volts here. But we're going to keep it all the same, just one battery. So let's just connect our power rails on this side so that we don't forget to do that later. Okay, so now it doesn't matter which side of the breadboard we use, they're all going to be interconnected. So there is our positive side of our motor controller connected. Let's connect the negative side. Slightly longer. So the 3rd pin down is ground. Okay. So on this side, the next 2 pins are the pins for the motor. So we'll switch to the other side, because we don't want to connect the motor yet until we have it in the model. So on this side, we have our 3 control pins for the Arduino, so we'll plug them in later. But we have our standby pin. Now you could connect this to the Arduino if you wanted to turn it on and off. I'm just going to make it positive 5 volts so that the motor driver is always on. So that is the 4th pin down on this side, and I'm going to connect that to the positive. So the motor driver board is going to be constantly on in my model, which is fine. Now, let me see. So that is everything on that side for the motor driver. So next we need our Arduino. We'll place our Arduino in like this. Push that down. Okay, so our PWM pin, that's going to go to pin 5. We need a longer bit of wire. So that's the very top pin here, goes to pin 5. Then our control pins are going to go to pin 7 and pin 8. So we have pin 7, pin 8. So 7. And pin 8. Okay. And that is all our pins on our motor driver except the two for the motor. So we'll put in our motor driver chip, fix it in place. Okay, so that's pretty solid in there. So now we want to get power to our Arduino. So we need a VCC pin, which is here. Connect that to the 3.7 volt line. And we need a ground, or a ground pin here. That's ground VCC. So now we have power. We check our diagram. We'll need. I guess we need to put the XB in next. So checking our pins here, all our control pins are on here. I've actually damaged part of this board with I had high power transistors in here trying to make an amplifier, and they got very hot. So luckily enough we only need this side of the board. So this breakout board has the pins marked on it. That's very useful. So we'll connect its power pins first. So VSS is ground. Connect that. And VCC is positive, 3.7. We need to connect our RX and TX. So we have TX of the Arduino, so that's the transmit. It has to go to data in on the Arduino, which is the 4th pin down on my side. It's the 3rd pin down on the Arduino. And data out of the Arduino has to go to the RX pin of the, data out of the XB has to go to the RX pin of the Arduino, which is the receive pin. So that's our Arduino connected up. So now we basically have our control end of our circuit done. So we'll need to start worrying about our LEDs from now on. Okay, so like I said, the next stage is the LEDs. So I have a couple of LEDs set up here. I have 2 red LEDs, that's going to be our brakes, and the forward voltage of these 2 LEDs is enough that we're not going to need a resistor on these LEDs. So if I measure the current here, you can see our LEDs are on no problem, and we're only drawing 5 milliamps, so not a problem. We have these 2 LEDs in series, that's absolutely fine. Next is our indicators. We have a 120 ohm resistor for these. LEDs are on. We have 15 milliamps, no problem. Exactly the same for the other side. So that's left and right LEDs. That's okay. So those 2 orange LEDs are in parallel, and they have one 120 ohm resistor. Okay. So just to clarify, one 120 ohm resistor going to both of these two orange LEDs, and the same for the other side of the tractor. Now I have a beacon here. I have 120 ohms on it as well, so it's the same orange LED, so this one's just a little bit brighter for the beacon, but it's 15 milliamps as well. So that's all okay. Next we have, I decided to put some LEDs into this tractor the first time I was looking at it. So if you've watched my videos in the past, you'll have seen me looking at this tractor before. So I already have headlights in it. So as you can see, it takes about 35. I think when they warm up a bit they go up to about 37 milliamps. So that's just about okay, and I'm going to see does that work okay with the Arduino, because I've never actually tried to put so much current from an Arduino pin before. So we'll give that a go, because it should be inside the limit. And we have green LEDs here, and they're taking about 20 milliamps to work. So this is just I just happen to have lots of different coloured LEDs, so I decided I'd put two of them in here and make the engine bay look green as well. So if we add all those values up, we come to 107 milliamps roughly. So we're well under the maximum current of 200 milliamps that the Atmega chip can supply. So I'm going to go ahead and connect all of those to a pin on the Arduino, or to individual pins. Not one of them exceeded the 40 milliamp limit from each pin, and cumulatively they're all below the 200 milliamp limit. So they should be fine to connect directly to the Arduino as they are. Now the final thing I have are these high or super bright LEDs, and I'm going to try and put 6 of these on the tractor. I'm going to put 4 on the cab and 2 on these little warning things that stick out the side here. I'm just going to stick those around just because I like having these very bright LEDs on my tractor models. I think they usually look pretty good. So that's the plan. These are going to require a lot more current, probably over 100 milliamps to power these. So now we're going to have a look at adding a transistor for this. Okay, so now we're going to have a look at a transistor to power these super bright LEDs. And the transistor I'm using is 2N3904, and we have emitter, base, collector. So our base, we're going to put a 1 k ohm resistor on that. On our emitter, we're going to put that to ground. So we're syncing the current here, so it's coming from the load through the transistor to ground. So we'll connect to the ground side of these LEDs to our collector. And now if we put positive 5 volts on the base, which is where this resistor is connected, we should see the LEDs come on. Okay, so now the LEDs are on, and our Arduino is only going to see 3 milliamps to turn on that switch. Okay, so that's fine. Now let's see how much current it's actually taken to illuminate those LEDs. So now I've switched the multimeter to send power to the LEDs. So the value that we're going to see here is the power that the LEDs are requiring. And now I'm going to connect 5 volts to the base of the transistor again to switch them on. So we switch them on. Okay, there we go. And it would appear we're only taking 50. Oh, no, there's more like it. It's gone up to 70 milliamps to power the LEDs. So that's not too bad, because these LEDs could go up to 25 milliamps, and this should add a nice addition to our tractor. They should be very, very bright, and that's basically what we want to see. Okay, so we want to add a switch to our circuit. So a little push button switch here. we're going to go to the diode symbol on our multimeter because we want to know which pins are going to have a connection. So let's pick the pin in the center, pin on the outside, and the other side. Okay, so when the switch is up, neither outside pin has a connection. If we push the switch in, there's a connection on the right and no connection on the left. Okay, so we're going to want to use the pins on the center and on the right for our switch. So let's take our battery. We want to connect the ground to the other grounds. That's fine. We take one of the wires, put it in the center, connect it to the battery. Take another wire, connect to the right, and connect to the positive rail of our breadboard. And if we look at our Arduino, power it up, turn it off. So that works fine. That's our switch sorted. So now it's time to move everything into the trailer so that we can test it on the tractor. Okay, so now we've moved the board into the trailer. We should wire up the LEDs first, I think. So we have a beacon on A0, so A0 is here, and we need that to go all the way over to the beacon, so that's quite far. So A0 over to the beacon over here, so on this side of the resistor. Okay. Then we have brake lights, and our brake lights are on pin 6. So need to go to here from pin 6, and pin 6 is here. So from here over to here. So that should be our brake lights. Then we have indicators, and indicators are on pin 2 and pin 4. So 2 and 4 are our indicators. We need a long open wire, so pin 2 here. So there's one of our indicators, and pin 4 is the other indicator. Okay. Now we need our floodlights. So our floodlights are pin 12. So pin 12 is down here, and we need that to go to our transistor. So that should be our floodlights. Now I'll have to run some wires from the lights on the front of the tractor back, so I'll make those connections and then we'll wire that up. Okay, so I've run a few wires back. Here is the ground wire for the LEDs. We have 2 wires here. Here's for the headlights. So the headlights should be going to they should be going to pin 3, which is a PWM pin. So pin 3 is in there. Okay. So that's pin 3. We have our green lights. The green lights I added here are not they're not a common feature on a tractor, so we're going to use one of the unused pins for this. So let's use A2. So A2 is unused, and when I say unused, I mean in the diagram it's unused. So if the pin is unused in the diagram and is free code in the code for the Arduino. In the generic code on the website, that is an empty option, and you just have to fill it in so that it turns that on when you send the right command. Now, take our steering servo. So we get ground and power. We have our signal wire, and our steering servo was pin 9, I think. No, our steering servo is in fact pin 10. Okay, so pin 10. That's pin 10. Our motor, that's the last two things. They just go into their pins on the motor driver. One final thing, our link servo. So we'll just add a few wires to it. So we need a ground, we need positive, and we need a signal. So our signal for the link servo is actually pin 9. So there's pin 9. Our positive and ground. So we'll just leave that in there. I'll test that out later. So we have connections on the back of the tractor here for the external servo and external serial, but we won't bother wiring them up yet. We can just plug them straight onto the Arduino here to test that. So that's no problem at all. Now that is the tractor wired, ready for testing. So the next step we need to do is to add the code, and that's going to be in the next video in this series. So make sure and subscribe, and you'll get an update of that video as soon as it comes out. You can actually tick an option to get email notifications about new uploads if you want, but I don't think it's the norm. So if that's what you want, click subscribe, and in your settings you'll be able to select email notification. So that is all I'm going to cover in this video, so make sure and tune in next time to follow the series. And if you like the video, give it a big thumbs up, and if you have any questions, post them either here or in the forum. And that's everything. Thanks very much for watching.